Hello, good morning students. I am Sheela D V from Department of Computer Science. I am from Soundarya institutions. So today I am going to teach a topic on transportation problem. The main aim of this transportation problem is to calculate the total cost to travel from one place to another place. So this is what we are doing. So in this transportation problem we have three types. There are three methods to get the total cost. So those three methods are nothing but NWC, that is the northwest corner rule. The another rule is least cost method, and the one more is Vogel's approximation method. So today I am going to teach you one by one what exactly we are doing this, and finally I will conclude telling you that which rule is the most feasible rule of all these three. So let's move on to the problem now. So before moving into the problem, I will just give you a small example. Now for example, this is your college and you can see this is your home. So you have to travel from your college to home, so this is what you do it daily. So for example, you take that there are three ways to travel from your college to your home. Clear? This is one direction, so this is the another path, and this is the another path, where each path takes different cost. For example, if you are traveling through any public transportation, so this path will take you nearly 10 rupees, this path will take you nearly 5 rupees, and whereas this path will take you 20 rupees. So as a human being, which path do you choose? So it's a normal human mentality where we choose for the minimum cost to travel from your college to your home or to home to your college. So obviously we choose this path, yes or no? So it's only regarding few kilometers. When it comes to thousands of miles, so then it is very tough for us to judge. So what would be the cost? So this is a problem where exactly we are going to solve now. Okay, so in this type of problem you can apply any of the rule and find the solution. So I will tell you exactly what it is. So these elements what you are seeing inside the cell, so these are called as Cij. So these are called as Cij. Cij means the cost to travel from one place to another. For example, if this is a college and this is your home, to travel from your college to home, so this can be the path, so this can be the path, and this can be the path. It can be any of the path, okay. So this is what we are doing. So remember my dear students, so these elements or these numbers what you are seeing inside the cell is known as the cost, that is represented by Cij. Clear? And generally we apply the operation research concept. So transportation problem is one of the operation research concept where we will be applying it in business field, okay. So now till now I gave you a very casual example. Let us move to we will think as a businessman. Now these are the demands that is being made by a customer. The elements what you are seeing, right, 20, 40, 30, 10. So these are the demands what is made by a customer, and this is the supply what an businessman can give, okay. So these are the supplies 30, 50, 20 means these are the number of product what a owner has, and these are the demands which are made by the customer, okay. So when we see this, what is now when the customer has made for 20 products, the owner has 30 products where he can easily send 20 products to him, and remaining 10 products he will have within himself. So next time when the customer demands for 40 products, what he does is he combines this 10 with some other set of products, and then he combines with that particular product. So this is how the problem is we are going to do it now. So now we will apply NWC corner rule for this problem and we will find the solution. So first step whenever we are doing a problem is we have to check whether the problem is a balanced problem. So what the meaning of a balanced problem is, whatever the customer has asked for the product, whether that much of supply is there with the owner, okay, with the businessman. So this is what we are checking. So first, to check whether the problem is a balanced or an unbalanced problem, you have to just calculate. For example, 50 plus 30 is 80, 80 plus 20 is 100. So this side, the businessman has 100 products. Let us come here. 20 plus 40 is 60, 60 plus 30 is 90, 90 plus 10 is 100. So when these both calculations are equal, so this way also it's 100 and this way also it's 100. When these both calculations are equal, we call it as an balanced transportation problem. Now this problem is a balanced transportation problem, so we will proceed with the rule. So second one is, in NWC, you have to choose a cell which is in the northwest. So you cannot take a compass here and calculate where is north and where is west. It's very simple. Just raise your left hand. The topmost cell towards your left hand is known as the northwest corner. So obviously we are going to start a problem with the northwest corner. So this is our northwest corner, and here we have to make some allocations. So what is this allocation is? An allocation is represented by xij, where you have to choose the min of A comma B. In the sense, so these products, whatever is seeing is all of A, and this whatever you are seeing is all of B. Means in these two you have to choose a min and you have to write it here. So that is very simple. So let us start the problem quickly now. So the brief explanation of the problem. Now, so I told you this is A and this is B. In this you have to choose a min. Obviously the min is 20. In 20 and 30 the min is 20. This you have to allocate to the northwest cell of your problem. So this is your northwest corner and you are going to solve it here. So in this 20 and 30, 20 is the minimum. So I will do the allocations. Always your allocation should be made here, okay, to the corner of your cell, okay. So this will not confuse you. So now you have to remove, since you have made the allocation, you have to remove this 20. So the 0 will remind here, and here you have still 10 products to supply. So you have sent only 20 to that particular cell. So this is how. So once the 0 is been made, so you cannot make any further operations to this particular column. You have to just shade this part so that it won't be confusing for you to do with the next step. Okay, so since this is 0, I am shading this part. Now let's come. Now again we will go to the, now when you consider, so don't see this part, you have to see only with this 3 column and these 3 row. Now again our uppermost towards the left hand is 2. So here you have to allocate a minimum. Now the minimum in out of 40 and 10, so the corresponding value for this particular cell is 40 and 10. So in 40 and 10 minimum is 10, so I allocate 10 here. Now there is no reminder here. Here there are still 30 products yet that you can still supply. So this has become 0. So let us shade this. Now don't see this first column and this first row, consider only this much of cells. Now again our uppermost cell is towards the left hand is 3. So here the products that the customer is asking for 30, but the supplier has 50 products with him. So in this min is 30, so I can pass 30 products here. So 30 will be, there is no reminder here, and the reminder here is 20. So just shade this part. Next you see the next cell, that is 2. Now you have to make allocation here. There is the 20 products. So in this min is 20 and 30. So 20 we can just put it here. This is min. What you have to do? So 0 remembers here, remains there, and here 10 remains. So since that is 0, I have to shade this. Okay. So now the 5, for the 5 we have to make. So 10 and 20, minimum is 10. Okay. So now you cannot make the further operations. So 10 will go here, 10 will remain here. So 10, 10. You can make the allocation directly. So all our allocations is done. Now the final step is to calculate the total cost. Now you have to calculate the total cost. So let me calculate the total cost. Total cost to make this product supply from one place to another place. So this is all the cost you have to calculate. So the first is 20. So this is the allocation you have made, 20 in, and the cost that is required to move from one place to another place. So it is 20 into 1. Okay. Then you can see the next cell, 10 into 2. Go with the next cell, that is 30 into 3. Then the next cell, 20 into 2. Next is this cell, 10 into 5. And the last cell is 10 into 9. So let's calculate this. So 20 1s are 20 plus 10 2s are 20 plus 30 into 3 is 30 into 3 is 90 plus 20 into 2 is 40 plus 5 into 10 is 90 plus 10 into 9 is 90. Okay, so we have to just calculate this. So this will give us the total cost to supply all this product from the businessman or the owner or the reseller to the customer. Okay, so you can just see, we'll all calculate the maximum thing. Oh sorry, this is 50 here. Okay, 10 into 5 is 50. So 90, 90, 180, 180 plus again 90 is 270, 270, 290 and 310. The answer is 310. So to supply this many products from one place to another place, the total cost is 310 when you use an NWC rule. So this is all about NWC. Next we will see with the least cost method. Yeah students, so now let us see with the another method called least cost method. The same problem I am solving it in least cost method. Okay, so this is another rule where we will be choosing the minimum cost and we will start with the operation. Okay, and this method is also called as matrix minima method. Means these are the numbers that are called as, that are inside the matrix. So in this you will be choosing a minimum number. So this is the meaning of matrix minima, or it is also called as least cost method. Now this is exactly different from the previous problem what we did, that is northwest corner rule. So that was straight away we just choose the uppermost cell and we started with the operation, but here it's not like that. We have to choose the minimum number and then follow the same procedure. Okay, so now let us see. So in this all the cost, okay, that is the Cij values whatever we have, which is the least value we have here. So you can see 1 is the least. So you have 1 here, here, here. So anywhere you can start. So it's better I'll start it from here. So since 1 is minimum of all the cost, I'll be starting from the 1 element. Okay. So now for 1, same way choose the particular A and the B. So in this you have to choose a minimum. So in the minimum is 20 here. So I'll write 20. So this is 0, remainder is 0 and here the remainder is 10. Okay, since this has become 0, you will be shading this part, means you will not use any particular Cij from this column for any other operation. So this is the meaning. So hence you people should not get confused and we should not consider this particular column. So whichever the particular cell or row becomes 0, just shade that part. So this is the best thing. So next, now you saw that in NWC we started here. So please don't do that. Now we have to choose the next minimum number which is there in this particular cell. So the next minimum number is again 1. So I'll start here. For this corresponding A and B is 30 and 10. So in this minimum is 10. I'll write 10 here. So here this remainder is 0 and here the remainder is 20. So I'll just shade this part. Okay. Now the next minimum number, again we have 1 here. We can start the operation again with the least cost. Here 1 is there. So take the corresponding A and B. A and B, the least cost is 10 here. Sorry, the least A is A. There, so 10 I am writing. So this will become 0 and the remainder here is 40. Okay. So since this is 0, I'll just shade this. Okay, so take the next least cost. So you have 2 here and here, anywhere you can do it. I'll be doing it because the second row I'll be doing it here. The corresponding A and B is 20 and 40. In this minimum is 20. So I'll write the 20 here. So 0 reminder, and here still you have 20. So just shade this since it has become 0. Okay, and the next minimum cost is 2. You can see 2 here. So here the A and B, corresponding A and B is 40 and 20. So you can write 20 as the minimum here, and the remainder is 20 here, and here is 0. So you have to shade this part, and it's okay if you don't shade also, unless there is only one cell where you can do the allocation. So this 20 and 20 you can just allocate here, and this remains 0. So if there is no any number reminding here in this place or in this place, okay, then your problem is correct. So this is one trick how you can track your problem and check whether you have done it correctly. So you can see there is all zeros, there is no any number reminding here, so everything is done. So now the next step is calculating the total cost. So let me calculate the total cost. Okay, so take like your previous problem, take 20 into 1 plus 10 into 1 plus 20 into 3 plus 20 into 2 plus 10 into 1 plus 10 into 2. Sorry, 20 into 2. So these are the number of allocations that we have made. Hope so I have written everything. 20 into 1, 10 into 1, 20 into 3, 20 into 2, 10 into 1 and 20 into 2. Yeah, I have written everything. So let's calculate this. 20 into 1 is 20 plus 10 into 1 is 10 plus 20 into 3 is 60 plus 20 into 2 is 40 plus 10 into 1 is 10 plus 20 into 2 is 40. So when you calculate this, so we'll make all the highest numbers. So this 60 plus 40 is 100, 110, 150, 150, 170, 180. So the total cost is 180. So you can say when we did the same problem in NWC, the total cost was 310. Now the total cost is 180. So when you compare the NWC and least cost method, we will conclude telling that this is the most efficient when it is compared with NWC. Okay. So because it has taken very minimum cost to travel with the same CIGs whatever was given there also. Okay. So it is 180. Now we will compare the same problem in VAM. Okay. So in VAM we will see, but actually VAM is supposed to be the most efficient rule other than NWC and least cost method. Now we will do the same problem in VAM, that is Vogel's approximation, and we will see what will be the total cost. Okay. Yeah, we will move on to the VAM now. Yeah students, we will take the same problem and solve it using Vogel's approximation method. This is another method and it is known as the most feasible method than other two, that is NWC and least cost method, and this is known as the most efficient method because when you compare with the total cost with the other two, you must get the least cost here also. Okay. So here least total cost I am talking about. Okay. So now let us start with the Vogel's approximation, and this method is quite lengthy when it is compared to NWC and least cost. Okay. So why it's lengthy, let's see now. Now you can see here you have the elements inside the cell, yes or no? So in this element you can just choose. Now first let us start with the first column. Choose the two minimum number. The two minimum number out of 3 is 1 and 3. Out of 1, 3, 4, you can see the two minimum number is 1. Next the minimum number is 3. You have to write the difference of this two number. Okay. So the difference of this two number is 2. So I will write it here. Okay. Now we will go with the second column. The difference between two minimum number 2, 2 is 0. Again write the difference between two minimum number, that is 1 and 2, the difference is 1. And here the difference between 4 and 1, so 4, 1, 9, so in this the difference is 4 and 1, so the difference we get is 3. Okay. So this is column wise, we are done with column wise. Now we will shift to the row wise, we have to do it row wise also. So now you can see that you have 1 and 1 where those are the two minimum number. So 1 and 1 is, the difference is 0. And here you can see the two minimum number are 2 and 1, the difference is 1. And here the two minimum number are 4 and 2 where the difference is 2. This is your first step where you have to write the difference between each and every row and column between two numbers. Okay. So other than this, now the next step is, in this difference number whatever you have got, choose the maximum number net. So in that maximum number is 3. So wherever you get the maximum number, you have to start the operation through that particular column. So this is the logic what we are using in Vogel's approximation method. Okay. So now 3 is the, when we compare with other number, 3 is the maximum number. So 3 get inside it, and in that 4, 1, 9, in this you have to choose the least cost. Always allocation should be made with the least cost. Out of 4, 1 and 9, 1 is the least, so I will choose 1, and for this particular A and B is 10 and 50. Okay. So 10 I will just make the allocation, this is 0, and here the remainder is 40. Okay. So whichever has become 0, just shade that part. And you can just make a mark like this that you have done through this particular column. Okay. So next we are not going to touch with this particular column. Now again find the difference, again the same thing, 1 minus 3 is 2, then 2 minus 2 is 0, then 1 minus 2 is 1. So here you are not supposed to do anything. Okay. Then 1 minus 1 is 0, then 3 minus 2 is 1. Then again the last one, 4 minus 2 is 2. So choose again the maximum number out of all this. So 2 and 2 are the two maximum numbers whatever you have. So you can choose any, either you can do through that particular row or this column. I will choose this. So in this 3 the minimum number is 1. So here I will make the allocation. The corresponding A and B is 20 and 30. The minimum is 20. So I will write 20 here. Okay. So this becomes 0, and here the remainder is 10. So since this is 0, I will just shade this part because we are not using it further. Okay. So now we will not go with this particular column. Now we will come again here, again 2 minus 2 is 0. Okay. 1 minus 2 is 1. Then again, so this we are supposed to do. We will take 2 minus 1 is 1. Okay. 3 minus 2 is also 1, and 2 minus 5 is 3. So out of all these differences, 3 is the maximum. So I will choose this particular row, and in this 2 is minimum. So I have to make the allocation here. For this corresponding A and B is 40 and 20. So minimum is 20, I will write 20 here. So here the remainder is 20, and this becomes 0. So just close this particular row now. Okay. So now you are not supposed to do with this particular column. You can do with this column but not with this row. Okay. This row you are not going to touch. Okay. So 2 minus 3. So you get minus 1, but you should not consider minus values here. So 3 minus 2 is 1. 2 minus 1 minus 2 or 2 minus 1 is also 1. So you cannot do it here. So 2 minus 1 is 1. 3 minus 2 is also 1. Okay. And you are not doing for this particular column. So 1, 1, 1, 1. So all are same. You can choose any of them and you can start. So I will choose this particular one. So 2 I have here. So in this 2, or you can choose that also. That one also you can choose. So when you come through this particular row, 1 is minimum. So for this one, the minimum A and B is 30 and 10. So I will do the 10 allocation here. Okay. So remainder is 20 and this is 0. So I will close this particular. Okay. Now you need not find the difference, straight away only there are 2 cells, so just compare. So in this 2 is minimum, so into the this 20 and this 40, minimum is 20, I will write 20 here. So this will become 0 and this the 20 is again remainder there. So I can see here 20 and 20. So just write this remainder here 20 and 20. Clear? So 20 and 20 are written, I have written here. Okay, so there is no remainder. So all the demands and supplies are been fulfilled. So now its final step, that is finding the total cost. So we will find the total cost now and we will see what would be the total cost using Vogel's approximation. Okay, so 20 into 1 plus 20 into 3 plus 10 into 1 plus 20 into 2 plus 10 into 1 plus 20 into 2. Okay, so these are all the allocations. Let us check once again. 20 into 1, 20 into 3, 10 into 1, 20 into 2, 10 into 1 and again 20 into 2. So this all the allocations are written. So we will find the total cost now. So 20 into 1 is 20 plus 20 into 3 is 60 plus 10 into 1 is 10 plus 20 into 2 is 40 plus 10 into 1 is 10 plus 20 into 2 is 40. Okay. So we will find what is the total cost. Now 60 and 40 is 100, 100, 140, 150, 160, 180. So here also you got 180 has the total cost to travel from one place to another place, but in many of the problems you will be getting the least cost in Vogel's approximation when it is compared with NWC and least cost method. Okay. So this is the total cost 180, in both you got 180. Okay. But how to conclude this is VAM is the most efficient when it is compared with least cost or NWC method. Okay. So by this I am ending my topic. Thank you students, have a good day.